The word arithmetic or arithmetic in my head, I think about adding. So the big idea with an arithmetic sequence is that you're adding to get to the next term. So it's a sequence with a common difference between terms. And I'm just going to put adding in parentheses as arithmetic and adding kind of make me think of the same thing. D, we're going to call it D, is common difference. I'm going to keep referring to what a D is, the sequence. That's common difference. This is page R53. Here are the two things that you're going to need to be able to write: the closed formula and the recursive formula for arithmetic sequences. So I'll write the general form here, and then we're going to practice it a few times. So the closed formula starts out a sub n, because this is a sequence. You take your starting term, and you add your common difference n minus 1 times. It seems weird, like, why am I adding it n minus 1 times? You don't want to add the difference to the first term. You don't want to start adding your difference until you get to term 2, 3, and 4. So if you plug in 1 right here, isn't 1 minus 1 0? So it gives me back my starting term. But when you plug in 2, you're adding your common difference once. When you plug in 3, you're adding your common difference twice or 10 times. That one is more important. The recursive formula, we're going to see it, but a sub k equals the term that comes before it, so we call that a sub k minus 1, plus the common difference, and we have to tell the person what the starting value is. All right, so we're going to write, that's kind of the goal. By Friday, to be able to write down a formula for a sequence yourself using kind of this formula. So here's an arithmetic sequence. How do we know it's arithmetic? First of all, I check to see that my numbers are evenly spaced. What's my common difference here? How do I go from 4 to -1, -1 to -6, -6 to -11? Minusing. So that's like adding a negative number. So I'm still adding, right? So I'm adding -5 every time. So my common difference could be positive or negative. It has to be the same between every term. My closed formula would be a sub n. Now I'm just going to fill in the stuff into this formula. What's my starting term here? 4, right? So I'm going to start with 4, and I'm going to add my common difference, which is -5, n minus 1 times. And that's it. You just wrote the closed formula for that sequence. It's not hard, it just takes a little bit of practice. So where did I start and what am I doing? I'm starting at 4 and I'm subtracting 5. All right, my recursive formula, I just say where I'm starting, I go to the previous term and I subtract 5. Right, recursive is just what do I do to the term that comes before it? And then I need to tell my reader, you need to start at 4 as your first term. And that's hard. So I'm not expecting you to be able to do that until we get to like Friday's quiz. And really, I just focus on the closed formula. Recursive, I'm going to have you use, but you'll have to write the closed formula. So why do we want to write a closed formula? Well, I don't want to generate 15 terms to get to term 15. I just want to plug in 15 right here and see what I would get. So I do 4 minus 5 times 15 minus 1. I'm starting at 4 and I'm subtracting 5 14 times. Does everybody have a calculator to try that? I have some extras. You guys have one or no? There's one in her bin. All right, let's see. You both have one? There's an extra here, yes, right? So here's an extra one. That's for Adele. You guys have one? You have one, something to use, right, Theodore? Okay. All right, so what'd you get? So we're starting with the number 4, and we're subtracting 5 14 times. So we should be at negative, what? Negative 66. Someone got it. So here's a big idea. Why would using the closed formula be more efficient than the recursive formula? How would I use the recursive formula to find a sub 15? I'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then I could use the 14th term to get the 15th term. You don't want to do that for a sub 100, right? You want to be able to just plug it in, right? So why is the closed formula more efficient? You can plug in n into a closed formula. So that's kind of like comparing, contrasting a closed versus a recursive. Recursive relies on the previous term. So you'd have to find term 14 to get to term 15. I don't need to find term 14 at all. I just plug 15 in and I'm good. So there's a lot of real world situations that are arithmetic because there's a lot of linear, right? Arithmetic is the same as a linear function, constant rate of change. So over time, over so many hours or over so many years, if things are changing at a constant rate of change, it could be represented by an arithmetic sequence. So this says, let's find the common difference and then find the closed formula and then find a sub 8. So how do I know this is arithmetic? What is it going up by each time? You should always check. Yes, this is plus 4. Yes, this is plus 4. And yes, this is plus 4. Because one thing you're going to have to do is decide if something is an arithmetic sequence, yes or no. So now I'm going to write my formula. I always write a sub n equals, what's my starting term? I'm starting at 7, and what am I doing? Adding 4 n minus 1 times. The n minus 1 is hard to get at first. Really, this is your y-intercept, and this is your slope, right? 4 is your slope. That's your rate of change. Your y-intercept is when you plug in the first term, right? You get 7. So kind of when we graph, we're plugging in term 1, but it's kind of like the starting value. So when we graphed, it was our y-intercept. All right, can you find a sub 8? So you're going to plug in 8. 7 plus 4 times 8 minus 1. Or you could just do 4 times 7 and then add 7. 4 times 7 plus 7 is what? 4 times 7 plus 7. What do you get? 35. All right, I'd like you to try for a minute by yourself. Example 3. See if you can write the closed formula and generate the 8th term. It should have been a sub n equals 2 minus 5 times n minus 1 because I'm going down by 5 every time. Now I'm trying a sub 8. 2 minus 5 times, basically that comes out to 7. So what is 2 minus 5 times 7? Negative 33, right? I heard someone say it before. Negative 33? Okay, so what have we done so far? We've written formulas for an arithmetic sequence. We might have to identify, is it an arithmetic sequence or not? Actually, that would be something good to add at the bottom. Non-arithmetic sequences. So be on the lookout for things that are not arithmetic. Here's something that's a common mistake. 8, 10, 13, and 17. So people might look at this one and think it might be arithmetic because what's the common difference here? I'm adding 1, then I'm adding 2, then I'm adding 3, then I'm adding 4. So they might see a pattern in what's being added, but it's only arithmetic if you're adding exactly the same amount every time. So this number would have to be 1 every single time. So that is a non-arithmetic sequence. Here's another one to be on the lookout for, because I want to make sure that you're actually, checking every number. What if I did 5, 7, 9, and 12? Just to see if you're actually checking. Why is this non-arithmetic? Well, I added 2, and then I added 2. But then what happened here? I added 3. So make sure when you're checking for an arithmetic sequence, you actually check that it's consistent every single time. Because I might throw one on the end here just to see if you're actually checking. At first glance, oh yeah, 5, 7, 9, that's an arithmetic sequence. I'm adding 2. But 9 to 12 is adding 3. Right? So it has to be the same every single time for it to work. All right, and here's an example where you have to use a little bit of problem solving. Find the closed formula for an arithmetic sequence whose fourth term is 20 and whose 13th term is 65. So what I'm going to do is kind of go 1, 2, 3. This is my fourth term. And then I go a little bit more. This is my 13th term, and it's 65. It's important, I would have to tell you this is arithmetic. What does arithmetic tell you? What's the definition of an arithmetic sequence? You are adding the same amount every single time. So if you're adding the same amount, you can figure out the total amount that you added and figure out how many times you had to add that amount. So what's the total distance between 20 and 65? I added a total of 45, so from 20 to 65. How many terms were there? From 4 to 13, how many times do I have to add? 9. So there's 9 terms, and a total of 45 was added. What's 45 divided by 9? So your common difference is 5. Your first step is to let's figure out our common difference. That's a little bit challenging. You got to kind of figure out, okay, how far did I go? How many terms were there? All right, D is 5. How does that help me get my closed formula? I don't know my starting term. How do I figure out my starting term? Yeah. Yes. So because I'm going backwards, if this was adding 5, I would need to subtract 5 to go backwards. Right? So if you were subtracting 5, you would add 5 to go backwards. So if I subtract 5, I like to write that out, but 15 and then 10. So my starting term was actually 5. That's a coincidence. Usually your starting term and your difference don't come out the same. That was coincidence only. So let's write it out. A sub n equals 5, because that's my starting term, plus 5, n minus 1 times. So I found my closed formula. Some of you who might like a shortcut, when your common difference matches your starting term, you could just write 5n. Isn't that 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5? So for those of you who like a shortcut, when your difference matches your starting term, it's just 5n or 9n or 10n, whatever you're multiplying by. Okay, find the 20th term now. So plug in 20 into the formula and see what you get. It's actually easier to use my shortcut formula. Remember I said 5n? Because then you could just do 5 times 20 in your head. But you could do 5 plus 5 times 19. Five plus 5 times 19 is the same as 5 times 20, right? That shortcut formula that I said. And what is 5 times 20? Or 5 plus 5 times 19? 100, right? An even 100. Where should I write that? A sub 20 equals 100. Because I wanted you to finish by finding the 20th term. So there's a lot of notation, but there's really only one formula that you need. So I'll just write that formula up here so you don't have to flip back and forth a sub n. So it's your starting term plus your common difference, and then n minus 1 times, so that you don't add it the first time. So you are going to take a little bit of time and try page 502. Page 502 is the practice on arithmetic. And number one, first is just determine if it is arithmetic or not. Oh, I said or neither. It should just say or not. Or not. If it's arithmetic, find the common difference. I'm going to do a couple practice problems. So I'm going to do 1A, number 3, and number 5. So if you want to pause the video and try 1, 3, 5, and then check your answers to get you started. So first, is it arithmetic? This is adding 1 every time. So I would write, yes, it's arithmetic, and the common difference is 1. Number 3, this is me just writing the formula. So I'm going to write it as a sub n. The first term is 7, and my common difference is 5. So I'm adding 5 n minus 1 times. And then on number 5, to generate terms of a sequence like we did yesterday, you're going to plug in 1 and see what you get. So when I plug in the number 1, 1 minus 1 is 0 times negative 3 would be 0. Then I'm going to plug in 2. 2 minus 1 is 1, so I would just get negative 3. When I plug in 3, I would get 2 right here. Negative 3 times 2 is negative 9. And then when I plug in 4, I'm going to do negative 3. Negative 3, times 3. So I'd get negative 27. So now you are going to try the rest.